Okay, so today we're looking at the trig identity of the Pythagorean identities, or the Pythagorean identity first. So it's the learning intention is obviously the knowledge of how this identity comes about, and we'll be successful if we can derive the identity and identities that come with it, and correctly use these identities to calculate or prove other facts. Okay, so using our unit circle, we've got x and y. Now we know that this is the units. This unit circle then would be in the formula of x squared plus y squared equals 1. Yeah, with the centre being 0, 0, so in the radius of 1. Okay, but you also know this as the x being of cos of x and the y being sine y. I haven't changed the radius. So rather than having x squared, I'm going to write cos of x, yeah, and we're going to square it. And then we're going to write, instead of y, we're going to write sine of y. And we're going to square it. And that equals 1, because nothing has changed. So therefore, we get the first identity that cos squared x plus sine squared y, or x, the same value, equals 1. Yeah, so instead of writing x and y, we'll just change them to thetas. Yep, so the angle. Okay, and notice that when we write square, we put the square on between the function and the degree. Yeah. Okay, so if that's the first identity, so cos squared theta plus sine squared theta equals 1, we're going to derive the other two. So let's divide this whole thing by cos squared. So cos squared theta plus sine squared theta equals 1. We're going to divide it by cos squared theta. Okay, well, cos squared divided by cos squared is just 1. Sine squared over cos squared, well, sine, if they're the same, that just sine over cos, it becomes tan. And the reciprocal of cos is sec. And as they're all squared, that the solution has to be squared. So the next identity that we have is sec squared theta is equal to 1 plus tan squared theta. Okay. So what happens when we divide that by sine squared? Okay, well, sine squared over sine squared, that's just going to be 1. The reciprocal of sine squared is cosec. Now this is cos over sine, which is a reciprocal of tan, so it becomes cot. And then that's the third identity. So we've got cot squared theta plus 1 is equal to cosec squared theta. Okay. And there are that's our three Pythagorean identities. Okay, let's do some examples. We want to prove that 1 over sine squared theta plus 1 over cos squared theta is equal to sec squared theta times cosec squared theta. Okay, so the reciprocal of sine squared theta, well, that's cosec squared theta. And the reciprocal of cos is sec. Okay, so the left-hand side equals that. But but we want to get to that. So let's actually stay with the fractions. Let's go back. Okay. Let's add the fractions first. So if I want to add the fractions, I want to actually go times that by cos, times that by sine, and the denominators multiply together. Okay, that's better. Okay, so if I've got cos squared theta plus sine squared theta, well, that's just equal to 1. And so what I get is I get 1 over sine squared theta and cos squared theta. Now the rules of multiplying fractions that's the same as multiplying like that. Okay, and as we said, sine, the reciprocal the reciprocal of sine is cosec, and the reciprocal of cos is sec, which is basically the right hand side. Okay. All right. So another example. So we want to use the Pythagorean identity to simplify 1 minus cos squared a. Okay. So if I look at this and rearrange, we have cos squared a plus sine squared a. All I've done is change my thetas into a. If I rearrange it and take the cos to the other side, I would get 1 minus cos squared a. So this solution of this is, do it in black, is sine squared a. Okay. Now if I've got cot squared theta minus cosec squared theta, that's very similar to that. I've got 1 plus cot squared theta equals cosec squared theta. Let's bring everything to one side. So I've got 1 plus cot squared theta minus cosec squared theta. That now equals 0. I want to keep this on the left hand side, and I want to take that constant to the other side. So I subtract 1 from both sides, and I get negative 1. So the solution to this problem is negative 1. Okay. Alright. We want to eliminate beta from the following pair and describe the relationship. So we've got x equals 6 cos beta, y equals 6 sine beta. Okay. So when I have this problem, what I'm going to do is I'm actually going to square the top and the bottom. Square the top. Square both equations. So what I would get is x squared equals 36 cos squared beta, and y squared equals 36 sine squared beta. Okay. Now what I'm going to do is I'm actually going to add both equations together. So if I'm going to add the left-hand side, that becomes x squared plus y squared. Alright, I'm going to add 36 cos squared beta to 36 sine squared beta. What I'll do is I'll factor out this 36. That's still x squared plus y squared. Well, cos squared beta plus sine squared beta, that's just 1. So 1 times 36 just comes 36. And now, like what we did from the start, this is just a circle with center at 0, 0 and a radius of 6. Okay. All right. Question 4. We want to show that sec 4 theta minus tan 4 theta equals to 2 sec squared theta minus 1. Okay. I've already got sec in my question, so what I'm going to do is I'm going to leave this sec here. Alright, so this is the left-hand side. Alright, I now kind of think, how can I write tan cot theta? Well, that's the same as that. Okay. And looking at my identity, tan theta, tan squared theta is the same as sec squared theta minus 1. Okay, so what I'll do is I'll write that down. So, tan squared theta is the same as sec squared theta minus 1. And that's still times by sec squared theta minus 1. Okay. Well, let's just expand this binomial product. So we get, that's going to become sec 4 theta, multiply them together and then double them, becomes negative 2 sec squared theta. Square the last term becomes plus 1. Alright, that's all subtraction. So the two negatives become a positive, and that becomes a negative. Well, that cancels out with that, leaving us just 2 sec squared theta minus 1, which is the right-hand side. Okay. Alright. Yep. And that's the last example. Cool. Thank you very much.